At t equals 0, car A is a distance capital D behind car B. Both cars travel with a constant speeds VA and VB to the right. Because VA is greater than VB, there's an instant little t equals big T when car A reaches car B. So car A is coming up from behind and is going to reach car B and eventually overtake it and pass it. Part A, how would T change? Is it going to increase or decrease in each of the following cases? If the distance is D, then the total time, capital T, is going to increase. It's going to be bigger because it's going to take more time to go a longer distance at the same speed. Increase. This thing right here, everything I just said is your explanation. So I'm not going to type it out, but it's going to take more time to go a longer distance at the same speed. Please include that in your answers. The speed VA is increased. So if we increase this, then T is going to get smaller. So it'll decrease. And that's because it's going to take less time to go the same distance faster, right? So you're covering the same distance, but you're moving at a greater speed, so the total time is going to be smaller. And then finally, the speed VB is increased, but remains less than VA. That means the total time has to increase. If B is going faster, so if this one's going faster, that's going to put more travel, so your capital D is going to increase. So it's going to take a lot more time to go that distance. All right, part B, starting with two equations of motion, one representing each car, derive an expression. This word right here, derive an expression, namely this, derive. It's not calculus, it just means show the steps to get to an answer or an equation. So this is show steps, derive is show steps. An expression just means an equation. Okay, so whenever you see derive an expression, that means show the steps to get to an equation. For capital T, in terms of VA, B, and D. Now the phrase in terms of, that means your answer has to include those. So you can't just have V1 or V2 or VC or VD. No, those aren't even choices. You have to have the answers. We know that VA represents the velocity of car A and VB is the velocity of car B. So that's your constraint. You've got to include those in your answer. So we're going to start off with the equation from our position versus time graph, where if we had a straight line, it looks like we're moving with a constant speed, right? So it's going to be a straight line here, or slope is going to be the same. We know that this equals y equals mx plus b. So then x is our y, slope is our velocity, the x-axis is our time, and then b is our initial position, our starting position, or x naught. So we're starting with that equation. For car A, we can say that our position is going to equal velocity of A times t, right? At t equals 0, so car A is going to be, the initial position is going to equal 0, so we don't have to write plus 0. And then for B, then we can say where we do have a starting position where that does not equal 0. So we don't know what it is, we just know that it's not 0, so we want to make sure we include it. Take that back, we do know what it is, don't we? The initial position for B is going to be capital D distance away from A. So our equation becomes x equals VB times t plus the initial position, capital D. Okay, so that's step one in deriving the expression. We picked two equations and What is the same about these? Is it our position? Is it the time? Or is it the velocity? It's got to be the position, because when car A catches up to car B, they're in the same exact position, right? The time is going to be a little bit different, but the total time, capital T, will be the same. So for right now, because these two equations these two x's represent the same position as one another, the final position for each one, we can set these two whole equations equal to each other. So we get VA times T equals VB times T plus D, capital D. Okay. Now, let's see, I'm going to subtract off VB times T, so that way I can have my T terms together. And what that's going to do for me is now I have VA minus VB, and I can just pull out the T to the front. Excuse me. Equals D. Okay, that's great, but I'm looking for total time, and the total time is going to be the time that it takes for these two positions. So this little t is now the big T, because we have determined that the total time is going to be the time that it takes for x to equal each other. And then we can divide each side by VA minus VB to get capital T. T equals D over VA minus VB. That is your answer. So to derive an expression, show the steps that's necessary to equate two things with each other. Okay, so you're going to normally need to pick an equation that you know, or one that's readily available or given to you in the problem. And then figure out what is the same between those. Well, we know the position has to be the same if car A catches up to car B. And then we know the total time for the whole situation has to be the same, because if car B is traveling for 5 seconds, car A takes 5 seconds to catch up to B. So then the times are the same. So big T, which was told to us that is an instant where they catch up with each other, is going to be the same. And that's what we did. And then we just used algebra to work our way through this. So we got our T terms together because we knew that those two would be the same, and that's what we needed to solve for. So we had two T's, and we know we need to solve for one. So we moved them all to one side, and that's what we did. That is derive an expression. What I would do now, please do it, because I promise you derive an expression does not go away. If you've taken any physics class before, you know that to be true. Pause this video, take out a separate clean sheet of paper, and try to derive the same expression for yourself. And if you mess up, then flip it over and try again. Keep trying. Do it until you have the steps down and fully understand what is happening.